Hi, so this session we will be adding and subtracting fractions, and these are some of the skills you have to remember when doing this. So if you haven't seen session 1 and you need to revise things like turning mixed fractions into improper fractions, then you have to watch session 1. Alright, so we'll go through some of these points. So when adding or subtracting fractions, you must have the same denominator. That's very important. Otherwise, you can't add or subtract your fractions. So the second point says that you can only add the numerators, so your top numbers, once you have made the denominators the same. So after this point, that's when you add your top numbers, and just remember your denominator won't change. If it's 8, it will stay 8. The third point, if you see any mixed fractions, you turn them into improper fractions. That would be your first step. Next point, remember that whole numbers are really over an invisible one. So for example, if you have 2, it's just the number 2, it's really sitting on an invisible one. So that would really be 2 over 1. Next point, your final answer must be in simplest form. So you must simplify your answers by dividing your numbers with the same common factor. Okay, sometimes you can't simplify your answers, but always check. And also, if your answer ends up being an improper fraction, like for example 9 over 5, you need to turn it into a mixed fraction. Okay, so if your answer is improper, make sure you turn it into a mixed fraction. And last point, remember that what you do to the bottom, you must do to the top. So if you haven't got any of these points, just write them down because they're all important. And if you follow these points and remember them, you can't go wrong. Now we'll start off with some basic questions, and of course they'll get a bit more challenging. Now with the first one, we've got 2 over 7, or 2 sevenths take away 1 over 7. Your first step is, do we have any mixed fractions? No. And then check, do we have the same denominator? Yes, we do. I see a 7 here and a 7 there. So now I can just subtract my numerators. So I will have equals 2 take away 1 is 1 over 7. See how I didn't subtract 7 and 7? Once you have the same denominator, it stays that number. Okay, so it was 7, I have my 7. And on this question, I'll show you another step of working out you can do to see this more clearer. So this one here, we're now adding these fractions. Once again, do we have the same denominators? Yes, we do. So now what you can do is, another way or another step of working out is, because 4 and 6 have the same denominator, we can just write 7 once, because they share the same one, and then write 4 plus 6 on top. Okay, this is the same thing as that. It's still 4 over 7 and 6 over 7, but we can write the 7 once to see how the 7 doesn't change. And then 4 plus 6, we then have 10 over 7. Now, we have finished adding our fractions, but we don't stop there. Let's check and see. Can I simplify 10 and 7? Is there a factor that can go into 10 and 7? No, there isn't. But I can see this is an improper fraction. The 10 is larger and it's on top. So I must turn it into a mixed fraction. So how many times does 7 fit into 10? I know it fits once, and remainder 3 over, and we keep the same denominator over 7. And that's our final answer, which makes more sense. Number 3, once again, let's do a check. Yes, we have the same denominators, which is 8. So I can say 1 plus 3, they're both over 8. And now 1 plus 3, I know, is 4 over 8. And I've almost finished, but I have a look and check. It's not an improper fraction, so I don't have to turn it into a mixed fraction, but I can see it can be still simplified. I know that 4 and 8 are both even numbers, and I can divide them both by 2. But then I realized, oh, hang on, 4 is a factor of 4 and also a factor of 8. And if you remember, factors are numbers that we can divide another number by. So I'll divide them both by 4. The higher the factor, the better, the less working out you have. So 4 divided by 4 is 1, and 8 divided by 4 is 2. And finally, my answer was a half, and I can't simplify it anymore, and I stopped there. Number 4. Now number 4 is starting to look a little bit different because you notice that we don't have the same denominators. I've got an 8 here and a 4. Now you can go 8 times 4 to give you 32 and 4 times 8 to give you 32. That can work. But let's just check. Can I turn my 4 into an 8? Yes, I can. If I times 4 by 2, it gives me an 8. And of course, what we do to the bottom, we must do to the top. And that means I don't have to change this at all. So that will help me later on. I won't have to do as much simplifying. If I keep my numbers smaller, that means less simplifying. So 6 over 8 doesn't change. I don't touch that fraction because my 4 times 2 is now an 8. And then 1 times 2 is 2. And you can see how 1 over 4 and 2 over 8, these two fractions are equivalent. That's why we must do the same thing to the top and bottom. Now, my next step is, well, I can write them under the same fraction 8, and I have 6 take away 2. And 6 take away 2, I know is 4 over 8. And have a look, we've got ended up with the same fraction as over there. So divide them both by 4. Divided by 4, I get a 1, just like here, and 8 divided by 4 is a half. And that is my final answer. So just remember that if you don't have the same denominator, you can make them the same. You have to make them the same. And always check if you can turn your smaller number into the bigger number you have. Now, you can try these questions before I do them. Have a go first and see how you go. So with the first one, question 5, I'll just change my color to black. Have a look at our fractions. We've got 3 over 12 plus 1 over 6. Straight away, I can see I don't have the same denominators, and I have to when adding fractions. So first do a check. Can I turn my 6 into a 12? Yes, I can. I know that 6 times 2 is 12, and what I do to the bottom, I must do to the top. So I end up with 3 over 12 plus 2 over 12. Because 1 times 2 is 2, and I can see I now have the same denominators. And you can do that extra step if you want to. They're both over 12, so we will have 3 plus 2, both over 12. And of course, 3 plus 2, I'll squeeze it in here, is 5 over 12. Okay, and now let's just check our final answer. Can we simplify this? No, we can't. They're not even numbers, so I can't divide them by 2. And 5 is smaller and it's on top, so that's a proper fraction. So I don't have to turn it into a mixed fraction. So that's perfect. We're done. Question 6. Now, if you remember that important point, whenever you have a whole number, so we have 3 take away 6 over 7. 3 doesn't look like a fraction, but it's actually sitting on top of an invisible 1. So our next step now is we have 3 over 1. Take away 6 over 7. I have to make my 1 and 7 the same. And I can turn my 1 into a 7 by multiplying it by 7. And what I do to the bottom, I must do to the top. And then we will have 7 and 7 on the bottom. And of course, 3 times 7 is 21. And 6 doesn't change. So I don't have to change this fraction. And I can see I now have the same denominators. Now you can add this step in where they're both over the same denominator, but I might skip that because I haven't got enough room. And my next step is, well, 21 take away 6, I know is 15. And we have the same denominator, which is 7. And I've now subtracted my fractions. But of course, do a double check. Can I simplify these fractions, these numbers? No, but I can see that 15 is on top and therefore I have an improper fraction because 15 is larger. So I must turn it into a mixed fraction. I'll squeeze it here because I can't fit it down there. How many times can 7 go into 15? Well, 7 times 2 is 14, so that's 2 times. Remainder from 14, 15, that's remainder 1. Over, we keep the same denominator over 7. And that's our final answer. And we're done. So 7, the same thing. I know that 2 is really over 1. So I'm going to write it out again so it looks a little bit neater because it's a bit crooked and all over the place. So I've got 2 over 1 now plus 1 over 4. And now I've got to turn my 1 into a 4, and that's easy. I know 1 times 4 is 4. What I do to the bottom, I must do to the top. Oops, sorry, it's just frozen. Oh, disappeared. Yeah, and I'll just rub that out. Okay. Oops, so we have times by 4, and times by 4. So 2 times 4 is 8. 1 times 4 is 4. Plus 1 over 4. And now I have 8 plus 1, which is 9. And 4 stays the same. And I'm done. But of course, do your final check. Can we simplify 9 and 4? No, we can't. But yes, it's an improper fraction. So how many times can 4 fit into 9? Well, 4 times 2 is 8, so it can fit in 2 times. And I will have remainder 1 over, keep the same denominator, 1 over 4. And that is my final answer. Okay? So remember, any improper fractions, you turn them into a mixed fraction as your final answer. The last one on this page, question 8, we've got 6 over 9 plus 3 over 5. So for this one, we need to now make the 9 and 5 the same. Let's do our check. Can I times 5 by something to give me a 9? Let's try. 5 times 2 is 10. No, I can't. So this is where it's a little bit different now. I can't turn my small number into the bigger number. So the fast way of doing this, it is important to think of the lowest common denominator or lowest common multiple, LCM. They're both meaning the same thing. But if you can't think of something, just multiply the numbers with each other. Because I know that 9 times 5 is 45, and 5 times 9, I'll squeeze it in there, 5 times 9 is 45. Actually, I might just write this out again. Okay, that's better. I have more room. So once again, multiply them with each other. So 9 times 5, I know, is 45. I must do the same thing to the top. And I know that 5 times 9 is 45. And the same thing to the top. So by doing this, by multiplying your denominators with each other, you will always get the same denominator. It may not be the lowest common denominator, but at least if you're in a hurry, you've made them the same. It just means that you may have to simplify more later on. All right, and now we have 6 times 5 is 30, and 9 times 5 is 45, plus 3 times 9 is 27, and 5 times 9, of course, is 45. And I have the same denominators. So I can add in this extra step where I put both my numbers over the same denominator. So I have 30 plus 27. And 30 plus 27 will leave me with 57 over 45. Okay, now I've added my fractions. Now our next step is, can we simplify 57 and 45? No, I don't think we can. 57, I can't think of that number being in my timetable, so we can't simplify it. But it's improper because 57 is bigger and it's on top. And 45 is on the bottom. Well, I know that 45 can fit into 57 once because I'm really close to 57. So 45 can fit into there once. Remainder, well, what's the difference between 45 and 57? So we got 5 to 50, 5 plus 7 leaves us with 7, 8, 9, 10, 11, 12. So the leftover is 12, and we keep the same denominator, over 45. Now just check, can we simplify 12 and 45? No, we can't. They're not even numbers, but be careful, even though they're not even, what if we tried 3? Let's see. So I know 12 divided by 3 is 4. Can I go 45 divided by 3? Let's have a look. Well, 3 into 4 can fit once, remainder 1. 3 into 15 can fit 5 times. So it does go into 45. So my final answer would be 12 divided by 3 is 4. Over 45 divided by 3 is 15. So that's my perfect answer, because now 4 and 15, can I simplify it any further? No, I can't. So sometimes you may not have even numbers on top and bottom, but it doesn't mean you can't keep simplifying. And always try maybe 3 or 4 or whatever the number may be. And a way you can do this is just how I divided 45 divided by 3. I got my 3 and said, how many times can 3 fit into 4? So once, carry the remainder on the next number. It's like you have the bridge. It's like saying 3 divided by 45, if you remember this bridge. It's the same thing I'm doing here without having to draw it. Can 3 go into 4? Yes, once. remainder 1. And can 3 go into 15? Yes, it can go 5 times. So you can do it this way, but a faster way is just to do it with 3 into 4, 3 into 15, and so on. But it's up to you how you want to do that. But always just check and see if it can be simplified further. Now, with our last 2 questions, they look more complicated, and I might actually do one more question after this that involves 3 fractions. So if you can do these 2 questions, these are actually probably the hardest ones because you have to turn mixed fractions into improper fractions, and you also have a whole number. And it just looks more confusing, but it's actually quite easy. So with question 9, we can see we have 2 mixed fractions. So my first step is to turn them into improper. So if you remember that important point that we looked at the beginning, and we know that to turn a mixed fraction into improper, we go times first and then plus. So I know that 2 times 5 is 10, and 10 plus 1 is 11, and we always keep the same denominator, which is 2. Take away, and 7 times 2 is 14, and 14 plus 3 is 17 over 7. Keep the same denominator. And now my next step is 2 and 7. I have to make them the same. I'll just rub out the bottom one and I'll write it up again because I haven't got enough room. Now, 2 and 7, they're not the same. Can I go 2 times something to give me 7? No, I can't. So I'll just go 2 times 7 and 7 times 2. Because that will give me 14 and that will give me 14. But of course, what you do to the bottom, you must do to the top. So 11 times 7 and 17 times 2. Now, don't be scared of having numbers that are larger, like 17 times 2. All we're going to do is add 17 twice. All right, now 11 times 7 is 77. And it's going to be over 14. Take away 17 times 2, or 17 plus 7 is 35. Over 7 times 2 is 14. I now have the same denominators. Now I have to subtract my numerators. So 77 take away 35 over 14. 77 take away 35, just say if I couldn't work it out, I can quickly set up a calculation. 7 take away 5, I can do that, that is 2, and 7 take away 3 is 4. So my answer is 42. So I'll just squeeze it here. 77 take away 35, yep, is 42 over 14. And now we can see 2 things. 1, it's an improper fraction, and 2, we can also simplify this. Both of these numbers are even, and I know straight away I can at least divide them by 2. Now I'm going to continue this at the top because I've used up all my space. So I'll just rub this part out and continue so it doesn't look too squishy and messy. Okay, so I've got 42 over 14. So if you wanted to, you can say how many times can 14 fit into 42? But it's actually better to simplify it first because it makes it easier for you when you have small numbers. Now, I can divide them both by 2, but I thought, oh, hang on, I know 7 times 6 is 42, and 7 times 2 is 14. So how about I divide them both by 7? That's a higher factor, and it will save me some time. Okay, and then I will have 42 divided by 7 is 6, 14 divided by 7 is 2. And can I keep going? Yes, I can. I know that I can go divided by 2 and divided by 2, but I just realized, have a look. 6 divided by 2 actually gives me 3. And that's my answer. The longer way of doing it is you could have divided by 2 again and divided by 2 again. And we would have had 6 divided by 2 is 3, and 2 divided by 2 is 1. And we know that 3 over 1, this becomes invisible, so we just end up with 3. So that's the other way of doing it. And let's just make sure I didn't make a mistake. I'll just bring my calculator up. And let's just double check, is 42 divided by 14 going to give me 3? So 42 divided by 14, it does give me 3. So I've done the right thing. So I could have went straight away 42 divided by 14, but I don't know my 14 timetables or my 42 timetables. So I had to simplify to realize. Now, I can't remember the question I had up before, but I'll make up another one. And I can't even remember what number we're up to. So I'll just call this one, I'll make a lucky guess, 11. And you guys know I have a bad habit of doing that, so you should be used to it. All right, so question 11, let's try this one. If I have 3, take away 2 3/4. Okay, now remember once again, if we see a mixed fraction, we have to turn it into an improper fraction, and that 3 is really over 1. So let's start by working out. I have 3 over 1, take away, times and plus, so 4 times 2 is 8, and 8 plus 3 is 11 over 4. We keep the same denominator. Now my next step is, well, I now need the 1 and 4 to be the same. So I know I can turn my 1 into a 4 by multiplying it by 4. So 1 times 4 and 3 times 4. So then I have them both over 4. And 3 times 4 will give me 12. Take away 11. Okay? And then 12 take away 11 I know is 1 over 4. And that is my final answer, 1/4. And I can do it. You can also do this one mentally. 3 take away 2 3/4. Well, I know that there's 1/4 left to reach 3, and that would be our answer. And we'll do one more question. Now, with this question, it's starting to get more complicated because we now have 3 fractions. And actually, there's a cool trick you can do, and that is you can just work from left to right. You can do 2 at a time. For example, I can just work with 6 over 8 plus 2 over 4. Work that out, and then when I get my fraction, add the half to it. And you can do it that way. But another way is sometimes when you have easier denominators, like 8, 4, and 2, they're not so complicated because I know that I can turn my 4 and my 2 into an 8. Sometimes it's not that easy. For example, if I had 6 over 9 plus 12 over 59 minus, I'll make up anything, 9 over 61. And I asked you, okay, can you get these denominators to all be the same? It is going to be quite hard because 59 and 61, they're odd numbers and they're large numbers. So it'll take you some time to figure out the lowest common denominator for all 3. Ones like this is where you put brackets around the first 2 fractions, you work these ones out, and just say 6 over 9 plus 12 over 59. Just say it came to 6 over 15. I've just made it up, but imagine that's what it equaled. Then you grab the minus 9 over 61, and then you work with these 2 fractions. So you can work from left to right. So keep that in mind. But for this one here, I'm not going to do it that way. I'm going to do it a faster way because, like I said, my denominators, 8, 4, and 2, are quite easy to work with. They're not tricky and large numbers. So I'm going to turn my 4 into an 8 to make it the same by multiplying it by 2. What I do to the bottom, I must do to the top. And my 2, I'm going to make it an 8 by multiplying it by 4. And what I do to the bottom, I must do to the top. Okay, so I'll be left with 6 over 8 doesn't change, but 2 times 2 is 4, over 4 times 2 is 8, same denominator, plus 1 times 4 is 4, over 2 times 4 is 8. And now I have all my denominators are 8, they're all the same. And we can add in this step, they're all over 8, and we have 6 plus 4 plus 4, and work from left to right. 6 plus 4 is 10, and 10 plus 4 is 14, and it's over 8. And we don't stop there. Yes, it's an improper fraction, but I can also simplify it first to make it easier for me. You can simplify it later, but I'm going to do it now. And 14 and 8, because they're both even, I'll divide them both by 2 and divide it by 2. 14 divided by 2 is 7. 8 divided by 2 is 4. I can't simplify it anymore, and now I'll turn it into a mixed fraction. 4 into 7 can fit once, because 4 times 2 is 8 and it's gone past 7. And the difference is for 5, 6, 7. So remainder 3 over, we keep the same denominator over 4. Okay, so keep practicing adding and subtracting fractions, but we have covered all the different types of questions you can have. So if you can do all of these, you're doing fantastically in fractions, and I hope that's a word. Bye-bye.